Again, recall that the price of a stock is simply the present value of the infinite stream of dividends. Well, suppose we have a situation where 1 period from now we have a dividend, and then after that the dividends grow at a constant rate of g per period. Let's look at what that actually means. What it means is here we have d1, the dividend in 1 period. In 2 periods we have d2, but d2 is simply equal to d1 times 1 plus g. 1 period later we have d3. That can be viewed as the previous dividend times 1 plus g. Or here we have d1, and if the dividends grow by 1 period, times 1 plus g times 1 plus g. And again, remember what we're doing, what the growth rate tells us is what the amount is of the dividend that we expect at different points in time. So again, the dividend is this case where the company is writing a check to the shareholders, and g tells us what the amount on that check is. We're not discounting, we're not getting any present values, it's just telling us that in 2 periods or 3 periods or 10 periods or whenever, this is what we expect the amount on a check to be if there's constant growth. And in particular, we can look in general, the dividend at any point in time can be simply expressed as the dividend from 1 period before to that period, or the dividend at time 1, d1, kind of that first dividend, the one that we expect in 1 period, and how many times does it have to grow to get to time t? T minus 1 periods. So again, we're kind of, since we're already starting here, and the first, it only grows once to get from 1 to 2, twice to get from 1 to 2 to 3, to get to 1 to t, it's 1 to t minus 1. So we know a couple of relationships. We know that the dividend at any point in time is simply equal to the previous dividend times 1 plus g. We know that the dividend at any point in time is simply equal to the dividend at time 1 times 1 plus g to the t minus 1, because to get from there to there, it grows by t minus 1 times. And what we know is that the dividend at any point in time, and let's make b a later point in time, is equal to a dividend at an earlier point in time times 1 plus g to b minus a, which captures the number of times, the number of periods that growth takes place. So again, if we have 3 and we're going out to time 7, it goes from 3 to 4 to 5 to 6. It grows 1, 2, 3, 4. 7 minus 3 is 4. So if dividends grow at a constant rate, there's some things that we know. That if we're given any single dividend and a growth rate, we can get the dividend at any other time, because we can simply figure out how many periods there are between the 2 points in time, A and B, how many times. So therefore, we know that if the dividend is this at this point in time, and it grows this much per period, we can figure out what it is at another point in time. If we have 2 expected dividends, we can simply figure out what the growth rate is. If you've got the first dividend is at this amount, the second dividend is this amount, we know how many time periods there are between the two, what's the growth rate that would allow the dividend to grow from A to B. Therefore, if we have any 2 expected dividends, we can back out the growth rate, and then we can use the growth rate to find the dividend at any third point in time. So there's a lot of information embedded that if you know the growth rate or 1 dividend or 2 dividends, that you can always find the third one, either the growth rate, or you can actually find with 2 dividends the dividend at any other point in time if you have constant growth. So let's take a look at a couple of examples. What's the dividend expected to be in 5 years? Dividends expected to pay, stocks expected to pay dividend every year forever. The return's 10%. That's not relevant for finding a dividend. Next dividends expected in 1 year and $1.40, and all subsequent dividends are expected to grow by 5.5% per year. Well, we basically have a dividend of $1.40 in a year, and we want to know what the dividend will be in 5 years, expected to be in 5 years. So it's just $1.40 times 1.05 to the first, to the second, to the third, to the fourth. $1.40 times 1.05 to the fourth gives us $1.73.4. And you can see exactly the path that the dividend is expected to take. We expect $1.40. 1 year later, we expect it to be 5.5% higher, which is $1.47.7. 1 year after that, which is 3 years from today, which is 2 years after the $1.40 dividend, we expect $1.47.7 times 1.055, which is $1.55.8, or $1.40 times 1.055 squared. A year later, $1.64.4, and year 5, which is 4 years after the first dividend, 1, 2, 3, 4, we expect $1.73.4. So let's look at a particularly, I think, challenging example. What do we expect the dividend to be in 4 years? So what do we expect D4 to be? Pay dividends every year forever. Next dividend is expected in a year. What is what we know? The expected dividend in 3 years is 212, and the expected dividend in 6 years is 238. And we want to find D4. Well, here's our strategy. Our plan is to find G. What is the growth rate that if we expect 212 here and we expect 238 here will get us there? And it's simply that we know that 238 is equal to 212 times 1 plus G to the first, second, and third. What's the G such that if 212 grows by it for 1, 2, 3 years, it'll be equal to 238? And now once we have the growth rate, we can say, okay, D3 is just, or I'm sorry, D4 that we want to know is just equal to 212, which is D3, times 1 plus G. Or alternatively, this mystery cash flow that we want to find times 1 plus G squared is simply equal to 238. So we actually have 2 ways that we can approach it when we get to step 2. So step 1, we know that the dividend in 3 years times 1 plus the growth rate to the third, so it goes from 3 to 4 to 5 to 6, so it's growing 1, 2, 3, is equal to D6. So that means 238, which is the dividend we expect in 6 years, is equal to 212, which is what we expect in 3 years, times 1 plus the growth rate to the third. So now just divide both sides by 212, take both sides to the power of a third, and so you'll find that that is equal to 1 plus G. Subtract out 1, use your calculator, and the growth rate is 3.93%. You have a dividend of 212, and it grows by 3.93% for 1, 2, 3 years. You wind up with 238. Well, so now what do we know? We want to find D4, so we know that D3 is 212. D4 is just 1 period later, so take 212, multiply it by 1.0393, and in 4 years we expect the dividend to be $2.20 to 20.3 cents. Alternatively, we know the dividend in 6 years expected to be 238, so we want to find what's the dividend that if it grew for 2 years at 3.93% would get you to 238. So just take 238, divide both sides of the expression by 1.0393 squared, and you get 220.3.